last time what we have studied is that we have seen through that as soon as current is passing through the wire, right? The magnetic field is produced around that particular wire, or you can say it can be clockwise, it can be anti-clockwise. Then we have seen that if current goes above, right, then we consider that magnetic field out of the page, or you can say current direction out of the page, and magnetic field will be dotted. So if dot means magnetic field out of the page, and if it's crossed, then into the page, which is thumb goes downward direction. Then why there is a need to make a solenoid? Remember that in a wire, if current passes through, then the magnetic field will be not that strong enough. Even if you increase the current, you have a limitation to increase the current. You can't increase the current as much as you want it, because in a single wire, the current will be maximum. There must be a limit for a wire, right? So what you need to do, you will actually make a solenoid out of the wire. How do you make it? You make number of turns. So the number of turns developed in a wire becomes it makes it a solenoid. So when you do a solenoid, or when you make the solenoid out of the wire, and then you pass the current, the magnetism will increase. Okay. So now, first of all, important thing is how to increase the magnetism. If somebody will ask you, you will answer, increase the number of turns in the wire. Second important thing is increase the current. Okay. So these are the two things which we have done till now. Any question from this topic till now? Okay. Now, once you understand with this, now because it's a solenoid, so in solenoid, you can have to produce, of course, when current will flow, it will turn into a magnet. But point is, if it turns into a magnet, then there must be a north pole, there must be a south pole. Now, how to develop a north and a south pole thing? We called it right hand grip rule. Now, what does it mean by right hand grip rule? Let's suppose this is the direction of a current, and current goes in this direction. Now, if you check this out, right hand grip rule is saying that if you make your hand in such a way that your finger curling show you the direction of a current, because your finger curls it like this, and current direction is this, right? So the thumb points out in the direction of the north pole, and what left behind is the south pole. I've shown you another diagram here. That is this one. Now you check this out, what exactly it is. Let me enhance it so that you will understand it properly. The very important point in this one is that if current flows from left to right, so basically, if these are the connections, so how will you actually curl your finger so that current direction? See, current direction will always be either in clockwise direction or either in anti-clockwise direction. If you go from left to right, the direction shows is anti-clockwise. Okay. And if you curl from the other side, I mean, if the current goes from here, then it will be anti-clockwise. Here the clockwise thing, and here the anti-clockwise thing. So if these fingers are telling you the direction of the current, then this thumb will direct you in the direction of north pole. Okay. Now here what exactly it is, the field is similar to produced by the bar magnet with the north and south pole. The strength of a field increases as the current increases, and the strength of field increases as the number of turns of a coil increases. Students, is there any problem in this to understand how this north and south pole will be developed? I will re-explain it once again. See, now check this out. Ibrahim, can you turn on your mic? I need to just ask you a certain question, so you will answer me. Ibrahim?
Okay.
Yeah. Okay, Ibrahim, now you tell me one thing. When current will go from positive side, what is the direction of current? Clockwise or anti-clockwise?
When it goes from positive to negative,
It's always, we are considering always positive to negative, right?
it's anti-clockwise, right?
It's anti-clockwise like this, right? So if it's anti-clockwise, how will you curl your finger? You will grab your hand this way or the other way around, because there are two ways. One from the behind of the coil and one is from the front of the coil. So which way you will do it? From the
From
behind or
behind.
from the behind? And if you, grab the coil from behind, where is your thumb points? Which way your thumb points?
Upwards. Left. On the left.
Right, right,
Okay.
right side. So when it turns on the right side, your right will be north and your left will be south. If, for example, your coils are like this rather than, and current goes from here, now you will grab it from behind or from the front? From the front, because this way, now the current direction will be clockwise. So now I want you to write a very tricky thing in that. Now, tricky thing means very easy thing to remember is, it's for your sake so that you will remember it. If current goes in such a way that it goes from right to left in an anti-clockwise manner, then the north pole will be on the right side of the coil. Okay. And if the current goes from the right side and the coil and such a way that coil, the current goes in a clockwise direction, then the right side will be the south pole. Armina, do you understand what did I say?
Yes, sir.
So here, when the current goes in that, the arrangement of the coil in such a way that current goes in anti-clockwise direction. Whenever it goes in anti-clockwise direction, the right side will be north and the left side will be south. If current goes from right to left and the coil will be like this, rather than it's like that, if it's like this, for example, Ibrahim, now what will be the north and what will be the south?
In anti-clockwise.
No, no. For example, now current is going this way and current is going like this. This is the direction of a coil. It's clockwise.
Okay.
So if it's
Yes.
clockwise, then the direction will be from the front. You're grabbing the wire from the front because front way, your fingers will turn in the clockwise direction. So your north will be this and your south will be this. Because there will be two arrangement of coils. Either your coil will be same somewhere like this, what is like that, or either your your coil may be like this. So if current will go from right side and your coil direction is like this, then north is this and south is this. Otherwise, it's north on the side and south on the other side. So it's all depending upon anti-clockwise direction and clockwise direction. If current goes in anti-clockwise direction from the right hand side, then the right side will be north and left side will be south. If current goes from right side in such a way that current direction will be clockwise, then left side will be north and right side will be south. If the direction is reversed, then you will do the respective thing. For example, if this is positive and current goes like this, now this is clockwise. For example, if I consider that current, Safiyullah, what do you think? Which way the north will be if I am considering the current from left to right in the same coil? First of all, if current goes from left to right, which way you think the current will go? Clockwise or anti-clockwise? Yes, Ibrahim?
Clockwise.
Clockwise. If it's a clockwise, then how do you grab your coil so that your fingers turning will tell you the direction of a current? From the front, from behind. This way or the front way? That way or the front way? I think so, from the front way. So this time, your north will be that side and your south will be that side. Okay, understood? Anybody have a question, please ask, because this is important. Safiullah, Yumna, Armina, Ibrahim, any questions till here?
No. No.
Understood? Good. Now I want you to draw that diagram. This is important. Once you discover which one is north, which one is south, then you just need to draw the diagram. Diagram is very simple. The magnetic lines starting from north and ending at south. So these lines are showing the arrows. Okay. And this is the north side. That's the reason this arrow shows from the north. lines are also passing through the center as well. Now, those lines which are coming towards south, the arrow shows towards the south. Same thing here. Okay, I want you to quickly draw that, then we will move forward. And I've already told everyone, Saturday will be our confirmed day at 8 p.m. PST. Okay, so Saturday will be confirmed at 8 p.m. and that day will also be confirmed for the past paper practice. Now, one thing I've told you, I have sent one past paper already on the group. I want you to download it and print it on and try to solve the topics we already done. Do not try to solve the other topics other than what we have done. Whatever you can do, do that and keep the questions which you do not understand and then we will solve it in the class. Okay. So from on Saturday, coming Saturday, I want questions from your side. Okay. I will send you one or two further papers. You will find out the list of questions which you have problem out of those questions, out of those papers which I will send it to you. And inshallah, on every Saturday till your examination, we will be solving the past paper from them. Okay. Understood?
Yes, sir.
What about you, Ibrahim, Yamna, and Safiullah?
Yes, sir.
Yes, sir.
And Yamna, you?
Yes, sir.
Good. Now, Ibrahim, my question is I want you to write the characteristic of the magnetic field written on the right hand side as well. Now, we have increased the number of turn, done. We have increased the current value, done. What else is further we can do so that current will, you can say magnetism in the wire will increase? What else we can do? Anyone?
Increase the number of coils.
We have done that. Then what else? When you say number of coils, it means number of turns. Okay. The further we can do that, the practical application will be motor. We actually put an iron bar within this coil because iron, we know that it's a soft iron, and soft iron means it will be a temporary magnet as well once the current will pass. As soon as the current will pass from the coil, the iron will become a current as well. I mean, will become a magnet as well. So it creates its own magnetism. So that magnetism plus that magnetism will increase. So that way we can increase or enhance the magnetism of the solenoid as well. And that thing, which I just told you, will come next, and that will be your motor. Guys, did you copy that?
Yes, sir.
Everyone? Now, once we understand that everything is like that, now what is the next thing we have? Now there is a small concept we already know: electromagnetism, and everything. That's what all related to. Now, what exactly it is? As soon as current will pass through, it will become a magnet, right? I told you previously that the coil, once you pass the current through, it become a magnet, but we need more and more strong magnet. So what do? You will put a soft iron within that coil so that magnetism will be more and more powerful in this case. Okay. So unlike bar magnet, which are permanent magnet, the magnetism of electromagnets can be turned on and off. We know that. How do we turn it on and off? As the current passes through, the apparatus, the system becomes magnet, and as soon as the current is turned off, it will be a journal from just a magnetic material with no magnetism. So when current flows through the coil, it produces a magnetic field. This field is temporary and is lost when the current is switched off. Okay. So strength increase by increase the current, increase the number of turns. The core is usually made of soft irons such as iron or memento. I want you to put a heading electromagnets and write few lines. Unlike bar magnets, which are permanent magnets, just write them quickly, whatever is written here, and draw the diagram as well. Okay. Students, did you copy? Safiullah, Ibrahim, Yumna?
Yes.
Okay. Let's move on that. Now, Which particular circuits these electromagnets are used? Electromagnets are used in relays. And now, what exactly is a relay? Relay is a device which is used to switch off and switch on small circuits. Right? These devices are used as a switch off and switch on. Like for example, in big circuits, rather than you're turning on and off by the button, these particular connections will be used to actually turn on and turn off the big supply current. Like example, I will give it to you. What happened? This is your armature. Now, when the word armature is used, don't be confused. Armature means an iron bar around which a coil is turned. Okay. When the current passes through this coil, what will happen, Ibrahim?
It will get charged.
Yeah, it will be turning into a magnet. And as soon as it will turn into a magnet, that particular thing which is connected to that, for example, it attracts that towards itself. And as soon as it attracts that towards itself, that will switch. Let's suppose if it is switches here, it will turn with that. I mean, it will switch to that. Okay. So this way, it switched off or it switched on. Because let's suppose if it is connected to this point, right? As soon as this become a magnet, that particular bar goes up. And when it goes up, it will open the circuit now. Now current will not flow from the circuit. So technically speaking, it's no more connected to the switch anymore. This type of thing is used in basically factories where might be you've heard that if temperature rises to certain temperature, it will switch off with the device. Otherwise, it will continue with the same device. So these particular devices, relays, are used to switch off or switch on the circuit. Okay. So a very big relay is used in cars for switching the starter motor because it draws a very high current. Remember that relay itself is not taking very high current. Okay. So what it does, it will simply turn on and turn off. It is used to turn on or turn off with the circuit. Okay. So relay means to turn on or turn off with the circuit. Now, some people will ask why there is a need to use a relay. Why don't we directly use it? So simple reason is sometimes you want to have a control in your hand that, for example, if current rises to this temperature, it will turn on or turn off the main supply. So for that reason, first of all, we use these electromagnets. Second thing is another very important thing that because it relay normally operate at very less voltage. So it will not consume any power consumption or anything. So that is the reason less power consumption. And secondly, control comes in your hand. And third thing, very importantly, power consumption, or you can say power loss, is not there in this case because this is not taking too much current. That is the reason why a relay is used in this case. Okay. Any problem? Any student? Any question?
Sir, can you explain it again?
My question is, see, first of all, what is relay? So they say a relay is a device which uses low current circuit to switch a high current circuit on or off. My question is, let's suppose at this point, a motor is operating. And you know that I already told you motor takes too much amount of current. Okay. So point is if motor takes too much amount of current, a big amount of current, right? So how do I control it? I have to have a person every time sits there and it turns on and turn off. So for that reason, instead of a person, what did I do? I will use a relay. And that relay is programmable relay, or you can say it actually as soon as the current passes through the circuit, that particular circuit from where the current is passing through, it will switch off. As soon as it will switch off, no current will be passing through the motor. So motor will be turned off. That's the first point. So that is the reason it's written as a relay is a device that uses a small current. The second major use of this one is your relay may use at 5 ampere, 5 volts, 20 volts, something like this, very less. So you can have, let's suppose, 2000 volts or 200 volts of circuit. You can control the circuit by just 5 volt of relay. So first thing is there is less power supply. Okay. So important thing is 5 volt supply is the less one, and you can switch off or on 2000 volt of battery. So for the power consumption, relay is very less. So no power loss, and secondly, your control comes in your hand. Okay. So this is the use. This is not in our course too much, but I want you to write this a bit. Do not need to, just write the circuit. Just write the few things in that. This is a small working for the relay is written. I can read it for you. When the switch in the low current circuit is closed. Now you can see that when current is not passing through, it turns the electromagnetic on when attracts the iron armature. Now what happened? When the switch in the low current circuit is closed, it turns the electromagnetic on which attracts the iron armature. The armature pivots and close the switch contacts in the high current circuit. When the low current switch is opened, the electromagnet stop pulling the armature and the high current circuit is broken again. Point is, when the current is passing through, that device become a magnet. As soon as it become magnet, it will switch to that point. Once it switch to that point, current start flowing. Let's suppose here you have a motor. As soon as when the current stop flowing from the armature, it become demagnetized and that switch comes back to this point and motor will be broken, or you can say the circuit of the motor will be broken and no more working will be took place in this case. Guys, any question in this?
Sir, can you explain the last part again?
See once again. You tell me, Ibrahim, when the current will flow, what will happen through the armature?
The magnet will be magnetized.
And when it will be magnetized, it will attract this point, right? As soon as it will
Yeah.
attract this point, what will happen? That part which is not connected to any point, it will connect to this point. Am I right? This point.
Yes.
And when it's connected, now if the main supply is coming by this way, the current start flowing. If it's motor or it's alarm or whatever it is, the current is flowing through. As soon as the current stop flowing, now what will happen?
It won't be
That
magnetized.
it actually open up once again and this button or this handle goes down and this circuit is open now. And when it's open, it's showing open circuit with no current in it and it will be broken again. That's what it's written here.
Okay.
Okay, understood?
Yes.
Good. That is called the relay. And I want you to quickly write it. Draw the diagram as well, guys. This is the working written and that is a diagram. In examination, sometimes what happens, the diagram will be given and they are asking you to how it works. So we should know how it works. Safiyullah, what is the benefit of using armature? What is the benefit of using a relay in the circuit? Or Armina, you, Ibrahim, Yamna, anyone?
Sir, it can be controlled, so it can be turned on and off at any time.
Yeah, that's the one thing. The best way or the best thing is actually it operates at a very low current. So very less power consumption. Very less power consumption means very less power loss. So you can control large current actually by using very small current. So a very large or very big current circuit like motors or factories and all those big factories, those big currents which are passing inside the factory circuitry, you can control by very small relays which operate at very less amount of current. So less power consumption or less power loss through the relays because they are operating at a very less or very small amount of current. This is the second important, uh, you can say, benefit of using these relays. Okay, so let's move on then. So one of the use is this, the one which we just, okay, another use is circuit breaker. We have talked about this circuit breaker in electricity. It's not in our course, but just for the sake of information, the circuit breaker also use the relay circuits. Okay, so it's not in our course, so I'm not going into the detail of how it works, but we should know that it's same like a switching thing. Okay, magnetic storage things are also use these particular device. Okay, now this one. Now that is very important thing. What is that setup? What do you think? What is it? Who will tell me this? Now, if you check this out, you can see two things in it. That is very important. You can see there are two permanent magnets, North Pole and the South Pole. Okay. And you will see a wire passing through a permanent magnet. Now, you tell me one thing. Once the current will pass through the wire, what will happen? Yes, who will tell me that? Yes, Ibrahim, what do you think? What will happen? As soon as the current will pass through it, what will happen? Safiullah, what will happen?
It will be magnetized.
No, now you were okay. Now what happened? As soon as the current will pass through, it become a magnet wire. Now there are two magnetism. One is permanent magnetism, or you can say permanent magnetic field, and the other one is that magnetic field which is produced inside the wire. What do you think these magnetic fields, these two magnetic field, what they will do with the wire? Yamna and Armina, what's your think? What will happen? Yes, what will happen? What do
The
you think?
wire will start to rotate.
Yes, these two magnetic fields is make that thing happen that they start rotating the wire. So in that way, what happened? The wire start rotating. So what happened? The magnetic field due to the current passing through it and the permanent magnetic field due to north and south pole, these two magnetic fields make this particular wire start rotating. Now, why it happens? There is a reason for this. Because the force actually applied due to these magnets, two forces are applied on the wire. One is in downward direction, the other one is in upward direction. And you can call these two forces as couple force. The couple force produced, and these couple force start rotating your wire in anti-clockwise direction and clockwise direction, depending upon. So that is what we called as, that particular phenomena will be used while we will be doing motors. Okay. So put a heading. The force acts on a current carrying conductor in the magnetic field, including the effect of reverse. No, that just right here. A force acts on a current carrying conductor in the magnetic field. Still here. Put a heading and draw that diagram and write it, please, quickly. That topic is the basis of how the actually in a motor, how the working of motor or mechanism of motor actually works, or how the actually motor works. So this is the base of it. If there is any problem in understanding that, let me know. It's just a start, by the way. We will see in the next few classes that how actually the motor rotates and which direction it will rotate. That is important. Students, I want you to go through that now, whatever I've taught you today, because this is a bit difficult task, a bit difficult thing. Inshallah, in the next few classes, we will try to finish this topic. We have motor. and then inshallah we will jump to generators, and after that we have transformers. There are very few what you call this numericals related to that, that is related to technically transformers. So within 1 week or two, this chapter gonna be finished, and then whatever time we have left with, we will do classic physics, and then we have astrophysics as well. So hopefully, as with the time is passing through, and so inshallah, once we finish with this topic, I've told you already that I set 1 day for the practice for the past paper as well. So now you start doing the past papers, which I will send it to you each and every, like I already send you one. Mostly I prefer doing paper 4 with you people, because paper 4 is a theoretical paper. For IGCSE is paper 4. For GCSE it's paper 2 technically. So we will do all the questions related to these topics. So I expect that you will bring some questions, some difficult question which you feel it difficult. You will bring it next time while we have a class. Especially I'm talking about Saturday. Okay. So I will ask you in the next few classes. The timetable I've already shared with you. The pre-Ramadan timetable will be followed. I already write there. I already wrote it in the group. So hopefully we will follow that timetable from Monday onwards. Saturday, the class set at 8 p.m. PST. Okay. Any questions, students?
No.
Armina, Ibrahim,
Sir.
Safiullah. Yes, Ibrahim. Any questions? Okay, then. Then take care of yourself, and the data has already been given to you. You just check it out, and then inshallah, maybe some more data I will provide you as well. So just go through it, and inshallah, see you in the next class. I think we have a class on Monday. I think check it out and check the timetable, and then inshallah, we'll see you in the next class. Take care. Bye.